This is segment 3. Alright, so what we're looking at is exact values trig. What's the big deal? Now, exact values trig, as I said, is the most important thing you bring to this subject. So if you don't have it, oops, and I'm even going to do that. Alright, so what we're doing is we're thinking about, this is the only thing I ask students to do repeat wise. Everything else verbatim. Everything else I ask you to learn the concept like the previous work we did. And if you remember the concept, you'll be able to apply it. That's what mathematicians do. This is the only topic I teach students where I ask you to take a blank piece of paper and repeat this. Okay, so it's a little bit formulaic, it's less scientific, but it works. So basically what we do is we start off with a triangle, an equilateral triangle, so they're all the same side, and they all happen to be 2. Okay, now we know inside a triangle, theta, the angle, there you go, we're starting to do it, is theta is what? 180 inside a triangle. The internal theta. Internal. Now that's pi, and we'll get back to that. So that means that each of these angles are the same, and if we break them up, if we divide that 180 by 3, we get 60 degrees for each of them. Okay, now this is where the next little problem starts. What about pi and all of that? So what you will have done at school, maybe in year 7 or 8, is you may have looked at the unitary method. Now I'm not teaching you this, I'm just filling in a gap. Okay, I don't want you to do it, I'm just showing you. So if I have 180 degrees equals pi radians, okay, what I can do is divide by 180 both sides, and so I get 1 degree and that's where the unitary idea comes from. Okay, so this is like the unitary starting point, and then for any conversion you can go multiply by whatever. So if you want to know 60 or 30 or 45, you just go 60. So you go 60 times 1 equals pi 180 times 60. So the right hand side will be 60 degrees. Cross the noughts off. 6 goes into itself 1, 6 goes into 18. That's the equivalent, pi on 3. And so you can go on ad nauseum with all of that using the unitary method. Okay, you might have learnt that a bit later on than year 8, I said. Now, I'm all for tables and learning tables, blah, 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 but I don't think we need that. I don't think we need any of it, frankly. I think what we need is this. So this is what I've taught students over the years. Okay, the bigger angle has the smaller denominator. The bigger angle has the smaller denominator. Alright, the next thing we're going to do is we're going to take our triangle and we're going to bisect it, literally in half. So what that means is that where we had a 2 here, it was made up of 2 1s. Now we've got a 1. Where we had a 60, a bigger angle has a smaller denominator. When you're under pressure, that'll help. And what's happened here? Well, this is no longer 60 degrees, it's the smaller angle, it's 30 degrees. The smaller angle has the bigger denominator. Okay, and what is the size there? What is the size? So the next thing we need to do is we do need to revisit Pythagoras. I'm going to call that x for the sake of argument. So what we've got with Pythagoras is a river, and across the river is the big paddock, and on this side of the river is the smaller paddock, summed with the larger paddock, and the two of those are equal to this paddock here. So this is the one with the 2, this is the one with the 1, and this is the one with the side x. Now they're square paddocks, so if we're going to write the equation, we need to write 2 squared as an area is equal to 1 squared plus x squared. I need you to be able to do that. This subject needs you to be able to do that, okay? Because we want to know what that x is up there. Now we've got a bit of undoing to do. We're going to leave all the squares on. We're going to leave all the squares on. What's the operator between the 1 squared and the x squared?
Addition.
Addition. So I'm going to do undo. I'm going to minus 1 squared. That was a bit cheeky, wasn't it? You're allowed to do that. Yes, you can. So we've got 2 squared minus 1 squared equals x squared. We can rearrange the equation. 2 squared minus 1 squared. 2 squared is 4, is 3. X squared is equal to 3. How do I undo the square?
Square root.
Now, strictly speaking, we should do plus or minus, but because it's a positive, it's a square root of 3. So this guy up here is the square root of 3. I need you to be able to do this without a textbook, without the internet, without anything. I need you to be able to get to that point. Because what I want you to do is I want you to be able to draw this out, not from memory, but from your reasoning, which we just did. The bigger angle has the smaller denominator, the smaller angle has the bigger denominator, and the sides are like that. Now this is the most important thing you'll learn in high school, as far as I'm concerned. Okay? Now, why am I telling you this stuff over and over and over again? I brought a young fellow through the university, got special permissions from the university, and did Maths 1 at the end of Year 9. Still in school. That was 2 years ago. That student nicked a high distinction. Just got a high distinction. Why were they able to do that? Because they knew what we've taught in these last 2 weeks. Okay? That's how important this stuff is. So if that person can do it, I don't consider them a genius. That person can do it, you can do it. Okay? This is not beyond you. So this is the important thing here. Now what we're going to do, one last thing, is we're just going to divide this by 2. And so what we'll have is our triangle. That's 2 equilateral. I'm just going to erase that. I'm just going to fix that. I want it to be of the proportion because I'm going to be banging on a bit about this. So this is divide by 2. So we're going to have divide by 2, divide by 2, divide by 2. Okay? So what we're going to have is 1, root 3 on 2, and half. The bigger angle has the smaller denominator, the smaller angle has the larger denominator. Now this is the one that's the gold. This is what it's all about. Okay? If you can get to there, I'm extremely happy. So that part there from me, this part here, I'll just put this up like this because this is the verbatim part. And I'm serious about this. Take a blank piece of paper, sit out in the backyard, sit on your balcony, sit on the toilet, I don't care where you sit, with a blank piece of paper, and just recreate that. All of that stuff there on the left hand side. If you can do that, you are going to solidify your knowledge and how it works. Now I'm not going to do the proof for the other triangle, but there is another triangle, and that's the triangle where the sides are the same. Okay, and it's also got a 1, but it's got a 1 over root 2 and 1 over root 2, and its angles are the same, and they are 45 degrees, and 45 degrees is pi on 4, so that's the other one you need. Those two triangles together will profoundly help you through. Now what we're going to do is we're going to take this information and we're going to bring 3 ideas to bear. We're going to bring proportion, longer, shorter, etc. We're going to bring plus, minus. Is it negative? Okay. longer, shorter, greater than, less than. That'd be another way to do that. And the last thing we're going to do is bring an association. Now, all students who develop in 4-unit maths have got this built in. They had to develop it somewhere along the line. Guess what you're doing this year? This subject, you're doing 4-unit maths too. So we need this. So what are these all about? Well, let's have a look at our triangle. That's the way I drew it originally. Can you recognise it there? Which one's the bigger angle? Which one's the shorter angle? Which one's the longer side? What about this one? Or this one? Which one's the longer side? Which one's the shorter side? Which one's the bigger angle? Which one's the shorter angle? Okay? So that's very, very important. So that's our proportion. The plus minus comes about from a unit circle, which we're going to have a look at in a second. And then there's the association. So we'll have a look at the association in a minute. Alright, so with our association, this is going back to school. Okay, so we've got Sokotoa. Not really a big fan of it, but we need to just express it. So, sine of this angle here is opposite y over hypotenuse. So sine theta is opposite over hypotenuse. Do we write numbers over 1? Have you ever seen that? We don't, do we? We just write 68. So what can I write here? Let's just split that out. Sine theta. Okay. Let me do it this way. What's another name for sine theta? What's another name for sine theta, people? Dun, 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 dun. Y. What's another name for y, people?
Sine theta.
Okay, so that's your association. Let's do the other one. Cos theta is going to be adjacent x over 1. Do I need to write x over 1? The Puritans will scream at me. Cos theta is equal to x. Alright, what's a new name for x, people?
Cos theta.
What's a new name for cos?
X.
Right, so it's interchangeable. Okay, so this lovely little triangle has given you one of the key elements in our use of this information. Okay, the next thing we want to do is consider this guy. Let's just do that quickly. Pythagorean. 1 squared is equal to x squared plus y squared. Cool. Let's do our, what's x? Another name for x
is cos.
Cos squared. Ooh. What's another name for y?
Sine.
Ooh. Dun, 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 dun. Now, if it's cos, for me, that's sec, isn't it?
Mm-hmm.
You can check that yourselves. Cos over cos is 1. Now, what's y over x? Y over x is 10. Y over x is 10, isn't it? 10. See how we're using it interchangeably? Y over x, 10 squared. Whatever the variable is. Very good. Let's divide by sine squared. So we get 1 over sine squared cos squared divided by sine squared squared over sine squared. And so we get, now that would be cosec. Cos over sine's upside down tan, which is cot. And 1. So there's your other one. Now these can be used in a number of ways, but you're going to need that. Okay, you're going to need to be able to pull them out of your head. Just go pluck. There I am. Exact values trig. This is what I need. There'll be other things that I think will be important too, but these are the mainliners. These are the ones that are going to stumble you up in the first instance. Alright, so that was a bit of an aside. I was a bit naughty doing that. But we go back to here and we use this. This is what we really want to do now. Okay, you're ready to do some 3-unit work. Okay, so let's do proportion, plus or minus, and association. So what we'll have is our unit circle. Now don't do all stations to central or anything like that. Don't need it. We're going to use a different method. Our triangles present themselves like this. That's our 30, 60, 90. That's our 45. Did you recognise it? They're both the same. And X and Y. And that's our 60. X and Y. They'll present themselves like this all the way around. That's all we're really interested in. Fundamentally, that's all we're interested in. Whoops, I've kind of messed those up a little bit, but you're getting the picture. Okay? And not only am I interested in what's happening at those places, at those angles, okay, I'm also interested in what's happening here, because that's 0. This is pi. This is pi on 2. This is pi on 2 once, pi on 2 twice. I'm giving you a hint to how we do this. Pi on 2 thrice. 3 lots of pi on 2, and we come back to 2 pi. So what's happening here? Now what you'll notice is that as we transition from this angle, 30 degrees, watch carefully please, as we go to 45 degrees, what's happening to X?
Gets shorter.
X is diminishing, isn't it? What's happening to Y?
Increasing. That's
increasing. Now ultimately when we get to the axis, what's happened to X and what's happened to Y? These are
X has diminished. Oh, sorry.
Disappeared.
Yeah.
So the width of X is 0. The height of Y is 1. So what happens down here? This is -1. At -1, the height, Y has disappeared, but X is now -1. What happens here? Y is now -1 and X is diminished. There it is, getting smaller and smaller. Now it started out here, smaller and smaller. This is the answer. This is the answer. Okay? So, for X in the interval, I'll make that theta. For theta in the interval, now that's a typical 3-unit question at school. Okay? Solve the equation. You had it in the MRS if you did the MRS. You're good people, so I assume you did. I'm still chasing the others up. Okay, so we've got to bring our association. Proportion, polarity, association. So let's go to our... which one is the bigger number? X or Y? Which one is the larger of the two? Proportion. Which one's got the longest side? X or Y? See how I'm phrasing it? Which one's got the longer one? X or Y? This number here is 0.5. Root 3 on 2 is 0.866 or thereabouts. So you can check that if you don't believe me. 3 root divided by 2. You don't have to always do this. There it is, 0.866. So the bigger number is, which one's bigger? Y is bigger. Good. Which one's positive and which one's negative? You see what I'm training you to do? I'm training you to use these concepts, these ideas, these associations. Which one's negative and which one's positive?
Y is positive, X is negative.
Great. Okay. So you've got the proportion and you've got the polarity. Okay, all we need to do now is the work. We're using the association. All right. And you did that using your association, by the way. So this is the way you do this. You always do this way. You start in the origin and you do X first. You must do X first. So what we've got is a small negative. You go to the tip of the one that you just did and you're going to do Y. You've got a long Y, up or down?
Up, because it's positive.
Okay, so the angle that we're looking for is that angle there. Okay, so the way that we're going to do this is we're going to put our imaginary circle in. That's the first 60. We missed the 90 with these ones. So 60, 120, 180 would be included, and so on and so forth. That's how we would do our counting. But we only need to count once. Now watch this very carefully. Okay? What's the base angle inside here? What's this one? In proportion, is it the larger or the smaller angle? Larger or smaller angle?
Larger.
Larger. The larger angle has the smaller denominator. So it's a version of that. Now I'm going to make even more fuss about this because I'm going to make sure there's a bigger space. Okay, you ready? 160, 260, dun dun, that's it. Okay, now I want you to grab your calculators, put it into radians. I want you to do cos 2 pi on 3 and then sine 2 pi on 3 in radians. Are they a match? Radians. 2 times pi equals divided by 3 trig function cos minus 0.5. Tick. Two times pi equals divided by 3 equals sine 0.866. Tick. Okay. Now, in a way, the calculator is redundant because you can do these in your head. Okay, if you use this method. Now, what did I do here that was different? I can't put not equals because it is equal, but I'm going to do it this way. That's what you're used to seeing. You had 13 years of training and that's what you see. What I'm training you to do is to split that up and say, oh, that's pi on 3, that's 60 degrees. In fact, that's 2 lots of pi on 3. That's a count, 2 lots of pi on 3. Okay? Now this method, it works. It just works. All of the things that we've done to this point here, they just work. Okay? So for example, one of the questions that was in the MRS was this. Now, what's this question asking? Use your 3 ideas. Proportion, association, polarity. What's this question asking about? Cos. What's cos? What's another name for cos?
X.
Cos is x. This question is asking about x. In fact, it wants to know the length of x. Is the length of x large, small, 1, -1, 0, and where is it happening, this length? Look at that fraction, pull it apart, put the space in your mind's eye. It's happening at It's happening at 3 lots of pi on 2. So this is asking us, what is the length of x at 1, 2, 3 lots of pi on 2? Well, what's the length of x? X is
0.
Dun, dun, dun. Okay, do you understand how it's working? Is it coming together for you? Because this is the answer. All the things you'll do in the 4-unit part, all the complex numbers and all that stuff, this is the answer. Okay, this is where you're going to get it from. So let's do another one. Let's do I'll forego all of that stuff, and I'll just say sine theta equals -1 on root 2, and cos theta is also equal to -1 on root 2. So use your association, your 3 ideas. What's the proportion? What do you notice about the proportion? Is there a longer, smaller than, or are they the same?
They're the same.
They're the same. So without even thinking, it's this one. What's the angle?
45 degrees.
Which is pi on 4.
Pi on 4. Yeah.
So without even thinking, you know this is about some variation of pi on 4. Which one's negative, which one's positive? X and Y are the same. Alright, so let's go do it. Start at the middle. We start with X. What do we got? Same size negative. Start at the end of X. Y, up or down?
Down.
Okay, so that's the one we're looking at. We've already said that it's some variation of pi on 4. So let's put the pi on 4s in. Now, pi on 4, that'll be count 1. Double it, it'll be 2 times, it'll be pi on 2. So it will count, we'll have to count that. We'll have to count that one. Pi on 4, we'll have to count that one. And that one. So we're going to start here. Ready? Count with me. 1, 2, 3, 4, 5. 5 lots of pi on 4. Okay? 5 lots of pi on 4. How easy was that? There's no all stations 2. There's no mucking around with fractions. There's none of that. It's just counting. If you can count, you can do this. Okay, so let me just do that one quickly. Pi divided by 4 equals times 5 equals, I'll put that in the memory. Let's have a look at sine. -707. Memory recall. Oh, what happened there? Memory recall. Why is that doing that? I don't know why that did that. Now what we're looking at, cos minus 0.707. So 1 divided by 2 square root 0.707 tick. Okay, so they're correct. Tick. This is a much more intuitive way to deal with it. People who deal with 4-unit get this. I would like all students in New South Wales to learn this method, but there you go. They get stuck on this other stuff, don't they? They get stuck on odd numbers, 78.2 degrees, and that's not where it is. The science is here, and this is where most of what you do in this subject and the next subject that you do will require this. Alright, so I encourage you in that. Encourage you to get a feel for all of that. You can make up your own questions and try them. You know, you can do your theta angles and just pair them up. Sine theta is root 3 on 2. A positive root 3 on 2. Cos theta, what's the other one that goes with a root 3 on 2? A half. Okay, so we can say minus root 3 on 2 and a half. So which one's bigger, which one's smaller, which one's which? Okay, What's the base angle? So we start with the cos. We've got a small positive, and we've got a large negative. So this one down here is the one we're interested in. What's that theta angle? Theta is equal to, that's 60 degrees. 60 degrees is, the larger number has the
Larger.
smaller
Smaller
denominator.
base.
Yeah. Okay. So we need to do our equations. We need to recognise that that's going to be in it because it's 180, but that is not, and neither is that because they'll skip across. So we're going to count 1, 2, 3, 4, 5. 5 lots of pi on 3. Okay, then you go put it into your calculator to check it, and you'll find that that's the correct answer. Okay, so just clear all that stuff. 5 times pi divided by 3. Put that in the memory. Do the sign of that. Minus 0.866, tick. And get the memory out and do the cos one. Oh, what did I do wrong there? I did something wrong. I mussed it up. That should be that 5. Cos half 0.5 tick. Okay. So this is very important. It might seem like an annoyance, but it's absolutely essential that you get your heads around this, please. Okay, I'm just going to turn the recorder off there.